When we talk about mechanical advantage of a simple machine, we know that levers and pulleys offer a mechanical advantage. Mechanical advantage is actually a number you can calculate, okay? And it's the number of times that a machine increases or decreases the amount of effort you need to use. Because remember, not all machines make your life easier. They don't all make you use less effort. Class 3 levers make you use more effort, but the result is greater. Class 1 and Class 2 levers make you use less effort. We saw that on the lab that we did. Okay? Now, mechanical advantage, even though we didn't learn this, I'm going to put it in the video because it's very simple. Mechanical advantage is a number. You saw that when we talked about the mechanical advantage of different levers and pulleys and stuff like that. Well, the mathematical calculation to determine what the mechanical advantage is, we have mechanical advantage, I'm going to call it MA, is equal to the load force, okay, divided by the effort force. Now, all of this is in newtons, because we know that newtons are the unit, and that looks like a W, but it's actually an N. Newtons are the units of forces. Now, we did Class 1, Class 2, and Class 3 levers where you measured your effort force. Okay, so if I look at one of your labs, if we look at the lever lab that we did, the first part of the lever lab, it asked us to compare the load force and the effort force that we measured on the spring scale for a Class 1 lever, a Class 2 lever, and a Class 3 lever. So in this case, the mechanical advantage, okay, for a Class 1 lever, so the Class 1, the MA was equal to the load force, and we had a 200-gram mass. And if you multiply 200 grams, okay, and you change that to kilograms, obviously, that's 0.2 kilograms, multiplied by 10 newtons per kilogram, that gives you a load force of 2 newtons. And if I look here at the data on Joelle's lab, her effort force that she measured on the spring scale was 1.6 newtons. So if you have a calculator and you actually divide 2 by 1.6, it'll give you 1.25. So it has a mechanical advantage of 1.25. If we look at Class 2 lever, do a different color here. So Class 2, MA was equal to 2 newtons for the load because it didn't change. And there's also 2 newtons for the effort. That gives us 1. And then finally, the Class 3 lever, the mechanical advantage was equal to 2 newtons for the load divided by 2.9 newtons for the effort. 0.69 mechanical advantage. So what does all this mean? Well, we're going to look at what the actual meaning behind these numbers are. So if the mechanical advantage is equal to 1, that means that there's no gain in using the machine. Now, there's no gain in the sense that it doesn't take less effort, but there still could be other gains because we know that machines have more functions to them than just making things easier. They can change the speed. They can change the direction of a force. Okay? This one, in the case of magnitude, it won't change the magnitude because it's 1. It's the same thing. What do you think happens if the mechanical advantage is greater than 1? If the number is greater than 1, do you think that's good or bad or what? What do you think?
I think it's good because it's better to have a lower mechanical advantage because the lower, the more work and the more effort.
So if your mechanical advantage is a number is greater than 1, this means you have to put in less effort. So all my lazy people, that's awesome. You want a high mechanical advantage. It means you have to do less work. Yay! Okay, whereas if we look at our class 3 lever, we know that a class 3 lever takes more effort. Okay, but the results, the reason behind using it is that it increases the speed and the magnitude of the force. Okay, so in this case, if MA number is less than 1, we're going to have to use more effort. Okay? That is mechanical advantage. It is always the load divided by the effort, and that gives us the actual number. If the number is greater than 1, yes, less effort. If it's 1, same effort. If it's lower than 1, more effort. Okay?